Hi, I'm Jared. Welcome to Fun Science Demos. Nothing says Halloween like ghosts, witches, bats, Frankenstein skeletons, and spiders. And we thought we would bring some science into your Halloween, and we're going to do that using the force of friction. So we've turned our Halloween monsters into friction walkers. And what happens is they use the force of friction to look like and to actually climb up one piece of string all the way to the ceiling. And then when I reduce the friction, they come right back down. And it's a cool game. I could have races to see how quickly I could get my monster to the top of the ceiling and how quickly I can get it to come down. And all of it is from the force of friction. And we're going to throw some math at you as well by looking at angles. So we've zoomed in on the back of our friction walker to see friction at work and how they work. You can see I have angled two straws. This is actually 20-degree angles. The string passes through the straws and the straws bend the string, and that's really where the friction's happening. At the top part of the straw and the bottom part, there's friction between the straw and the string. Watch what happens to my climber and my straws and string as I just simply pull the string back and forth. You can see my climber go back and forth, side to side. One straw straightens out and the other one goes on more of an angle. Well, as the straw straightens out, it reduces the friction. As the other straws angle, they actually have more friction, which holds the climber and prevents it from slipping down. And now I can climb. And then I can let it come down. Friction. Friction climbers are fun, but we want to actually collect some data. And to do that, we're going to change the angle of our straws, which changes the amount of friction. We want to see how they work. So we've zoomed in on our bat so we can show you how to make this work. So you flip it over, we're going to actually start with two straws that have 0-degree angle to them. So I drew two straight lines. The first straw I taped along this straight line, and the second little bit of straw I'm going to tape along the other line. Get it as straight as I can. Can be a little tricky, so take your time. And again, this has 0 degrees to that angle. It's totally straight. We're going to see how much friction is created when the string rubs against the straw and see if we can actually get our bat to climb with 0 degrees. Let's see how it works. So these lines are completely parallel. Now I need to fish some string through the straw. I have this string attached to the ceiling. The other end of the string. And now we're ready to see how this climbs. Now, so I'm going to see how this bat climbs with my straws completely parallel with a 0-degree angle. Now, I'm going to have the back facing you so you can see what's going to happen. And all I'm going to try to do is the same thing. I'm going to move the string up and down. And you can see the string just slides through the straws because there's not enough friction. The angle is what creates the friction. So I don't have any angle and I have 0 friction. So it's not climbing no matter how fast I pull. So I have to create friction. I'm going to do that by pulling the string apart. And you can automatically see the string grab the sides of the straw. I've created friction. So now tug one side, tug the other. One side, the other. And you can see if I create friction by spreading the string, I can get my bat to climb. But it doesn't work that great if I put the string right next to each other. So the best way to change the friction with our friction climbers is to change the angle of our straws. So here, follow the progression. These straws are angled at 5 degrees, and you can see they're not parallel. Now we go from 5 to 10 degrees, to 15 degrees, to 20 degrees, and you can see the angle of the straws change. The question I have, is it possible to angle the straws so much and increase the friction so much they won't even climb up the string? Is there a difference between 5 degrees and 6 degrees and 7 degrees? Could we actually fine-tune our friction walkers with that much detail? That's science. So let's try our 10-degree angle to see how that compares to our 0 degrees. This is Frankenstein. I'm going to keep the back to you. I have it all threaded up. Get him to a working spot. Hold my strings parallel And I think I can see a little bit of friction happening in those straws and the string. Here we go. Let's see if I'll climb if I keep the string together. And what do you know? I do not have to separate the string. There's enough friction for him to climb all the way up. I wonder if I increase the friction, he'll climb better. So let's spread the string a little bit. Not really. I get enough friction with the string parallel, and then he comes on down. So Frankenstein was at 10 degrees. Our skeleton is now at 20 degrees. And we'll try this out and see if we notice a difference. And right off the bat, you can really see the friction. You can see the string grab on the straw. He's on there really solid. Let's see how he climbs. Keep the string parallel, start to climb. Looks like the skeleton's climbing. It looks like 20 degrees is climbing just fine. Then we let him slide. Now you'll notice it's harder to get him to slide. Why? Why would it be harder to get the skeleton to slide? Because the straws are angled so much, it's creating a lot more friction between the straw and the string, and it doesn't slide down as easily. So interesting. Now we're going to do something really interesting. We have 3 different monsters, Frankenstein, skeleton, and ghost, and all of the straws behind them are at different angles. And I want to see if some of them will climb faster than others. So here we go. We'll even climb all at the same time. Let's try. Here we go. Now you can notice right away, this ghost was catching up to the skeleton and climbing much faster. Well, his angle was 15. The skeleton was at 20. Does angle impact friction, which also impacts the speed in which they climb? And the answer is yes, 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 yes. If you want to learn more about friction and forces, check out our YouTube channel, Funsciencedemos. Science is so cool, especially when you can find it during Halloween. Race you to the top.